Hello students, in this session we'll discuss about physical as well as chemical properties of carboxylic acids. First let us discuss physical properties of carboxylic acids. Lower members of monocarboxylic acids having carbon atoms, okay, lower members of monocarboxylic acids having carbon atoms C1 to C3 are pungent smelling liquids. Then carboxylic acids between C4 to C9 are oily liquids, and above C10 are solids in nature. The boiling point of carboxylic acids are more than those of the corresponding alkanes having the same molecular mass. And this property is because of intermolecular hydrogen bonding in carboxylic acids. Now we'll discuss chemical properties of carboxylic acids. First, reactions involving cleavage or breaking up of carbon OH bond, COH bond. Okay. First, formation of anhydrides. When carboxylic acids are heated with the phosphorus pentoxide, carboxylic acid is RCOOH plus. When carboxylic acid is heated with the phosphorus pentoxide P2O5 or concentrated sulfuric acid, you are going to get anhydrides R COO CO R plus H2O. This is known as anhydride. Now we'll discuss one example. When acetic acid is heated with phosphorus pentoxide or concentrated sulfuric acid, dehydration takes place. Elimination of a molecule of water takes place. In this case here, elimination of water of molecule takes place. And if acetic acid is taken, then you are going to get acetic anhydride. And I will write that reaction. When acetic acid is heated with phosphorus pentoxide or concentrated sulfuric acid H2SO4, dehydration takes place, removal of a molecule of water takes place, and you are going to get compound anhydride, that is acetic anhydride RCOO COCH3. This is acetic anhydride plus a molecule of water plus H2. This is how we can prepare acid anhydrides starting from carboxylic acid. Now we'll discuss esterification reaction. Already we have discussed esterification reaction in the chapter alcohols. Okay. When carboxylic acids are heated with RCOOH, carboxylic acids are heated with alcohol. Carboxylic acids are heated with alcohol in the presence of dehydrating agents such as concentrated sulfuric acid. Esters are formed, and this reaction is known as esterification. Sulfuric acid is used to remove the water molecule formed during the reaction. Otherwise, hydrolysis of esters takes place. Okay, carboxylic acids reacts with alcohol or heated with alcohol in the presence of concentrated sulfuric acid, esters are formed, and this reaction is known as esterification reaction. Now we'll discuss one example. Example, when acetic acid is heated with CH3COH, acetic acid is heated with ethyl alcohol in the presence of dehydrating agents such as concentrated sulfuric acid. Just heat it, you are going to get ester, ethyl acetate ester, CH3COO C2H5 plus a molecule of water. This is ester, ethyl ethanoate, ethyl ethanoate. This is also called as ethyl acetate. Common name ethyl acetate. This reaction is known as esterification. This is acetic acid, ethyl alcohol. This reaction is known as esterification reaction. Next reaction is formation of acid chlorides. Formation of acid chlorides. Here the carboxylic acids when react with the PCl5, carboxylic acids when reacts with the phosphorus pentachloride or phosphorus trichloride or thionyl chloride, you are going to get these acid chlorides. Now we'll discuss reactions one by one. RCOH, carboxylic acid, reacts with the PCl5 in the presence of pyridine as a catalyst. You are going to get acid chlorides. Here we can follow a simple technique to write the product. Break this PCl5, write one Cl here, another Cl here. What is left? PCl3, write down PCl3 here. Then the product is RCOCl, acid chloride, RCOCl plus POCl3, phosphorus oxychloride plus HCl. We can follow a simple technique to write such type of products when there is PCl5 in the presence of pyridine. Carboxylic acid reacts with phosphorus pentachloride, gives acid chloride plus phosphorus oxychloride and HCl. Pyridine is used to absorb HCl formed during the reaction. Next reaction with the PCl3, RCOOH plus PCl3. Here 3 molecules of carboxylic acids are required for this particular reaction. You are going to get acid chloride RCOCl plus phosphorus acid H3PO3. This is carboxylic acid phosphorus trichloride. You can have one more reaction with thionyl chloride. Carboxylic acids reacts with thionyl chloride also, RCOH. This is carboxylic acid reacts with thionyl chloride SOCl2 in the presence of pyridine as a catalyst. You are going to put here also. You have to follow simple technique to write this product. Here make like this, write one Cl here, another Cl here. What is left? SO, write down SO here. So RCOCl, RCOCl plus SO2 gas plus HCl. This is acid chloride. This is thionyl chloride. Associated with thionyl chloride, and this is acid chloride. And these are the general reaction of formation of acid chloride starting from carboxylic acid. Now we'll discuss only one reaction with the reaction of one carboxylic acid with phosphorus pentachloride. Example: Acetic acid reacts with phosphorus pentachloride CH3COOH. Acetic acid reacts with phosphorus pentachloride PCl5 in the presence of pyridine as a catalyst. You are going to get CH3COCl, CH3COCl plus POCl3 plus HCl. This is acetic acid, acetyl chloride CH3COCl, acetyl chloride. This is example of formation of acid chloride starting from carboxylic acid. Next reaction is formation of amide or action of ammonia on carboxylic acid. First is carboxylic acids RCOH. Carboxylic acids reacts with ammonia. Here carboxylic acid is acidic in nature, ammonia is basic in nature. Neutralization takes place and you are going to get a salt, ammonium salt of carboxylic acid RCONH4. Ammonium salt of carboxylic acid. Here just this is neutralization reaction. Just heat it. It loses a molecule of water. Dehydration takes place. You are going to get acid amide RCONH2 plus a molecule of water. This is acid amide. And this is carboxylic acid. And this is ammonium salt of carboxylic acid. Ammonium salt of carboxylic acid. Carboxylic acid reacts with ammonia to form ammonium salt of carboxylic acid, which on heating loses a molecule of water to give acid amide. Now let us discuss one example. When acetic acid CH3COOH, when acetic acid reacts with or neutralized with ammonia, you are going to get ammonium salt of acetic acid, that is ammonium acetate CH3CONH4, ammonium acetate, which on heating, this is acetic acid, which on heating loses a molecule of water and you are going to get acetamide. Acid amide, here acetamide RCO CH3CO NH2 plus H2. This is acetamide. This is first example. Now let us discuss one more example. Benzoic acid. Benzoic acid reacts with ammonia. Benzoic acid reacts with ammonia. Here also neutralization takes place and you are going to get ammonium benzoate, COONH4, ammonium benzoate, which on heating, just heat it, loses a molecule of water and you are going to get benzamide, CONH2 plus a molecule of water. This is benzamide. Benzoic acid neutralized with or reacts with ammonia forms ammonium benzoate, which on heating loses a molecule of water and it forms benzamide. Next example, when phthalic acid reacts with ammonia, gives ammonium phthalate, which on heating loses molecule of water. It loses 2 molecules of water and it forms phthalimide. Phthalimide on further heating strongly loses ammonia molecule to form phthalimide. This is phthalimide. This is phthalimide. Phthalimide on strongly heating loses a molecule of ammonia and it gives phthalimide. This is the third example. Now here we'll make one note. Acid amides formed is heated with phosphorus pentoxide. Dehydration takes place giving alkyl cyanides RCO NH2. This is amide. On heating with phosphorus pentoxide P2O5 loses a molecule of water and gives, or dehydration takes place during this reaction, you are going to get alkyl cyanides. Alkyl cyanides are formed and this is acid amide. Acid amides on heating with phosphorus pentoxide, dehydration takes place and giving alkyl cyanides. Now we'll discuss reactions involving COOH group. Reactions involving COOH group. First is reduction. Carboxylic acids are subjected to reduction using lithium aluminum hydride. Carboxylic acids are reduced using lithium aluminum hydride. Gives primary alcohols RCOOH. This represents carboxylic acid in general. As the general formula, reduced using lithium aluminum hydride, a reducing agent, gives primary alcohol plus a molecule of water. This reaction known as reduction. Now we'll discuss the decarboxylation reaction of carboxylic acid. When sodium salt of monocarboxylic acid, that is RCONA, this is sodium salt of monocarboxylic acid, is heated with soda lime, that is mixture of sodium hydroxide and calcium oxide. Sodium salt of carboxylic acid is heated with soda lime. It is mixture of NaOH and CO in the ratio 3:1. 3 part of sodium hydroxide is mixed with 1 part of calcium oxide. This mixture is known as soda lime. Heated with soda lime. Decarboxylation takes place. Removal of carbon dioxide takes place, and carbon dioxide is this hydrocarbon is formed. You're going to get RH. This is hydrocarbon plus Na2CO3. This reaction known as decarboxylation. Here you can eliminate Na2CO3 like this. Na2CO3. Na2CO3. Na2CO3 eliminated, then link this R to H. So this is hydrocarbon. And this reaction known as decarboxylation reaction. Now we'll discuss example. When sodium acetate is heated with soda lime, sodium acetate CH3 COONA is heated with soda lime, methane is formed CH4 plus Na2CO3. This is example of decarboxylation reaction. This is sodium acetate. This is methane. This reaction known as decarboxylation reaction. Here we have to make one note. During this decarboxylation reaction, the alkane formed will have one carbon atom less than that of original acid. This sodium acetate is the salt of acetic acid which contains two carbon atoms, and hydrocarbon formed in this case is methane. It contains only one carbon atom. So this reaction is used to decrease the length of carbon chain by one carbon atom, or we can decrease the one carbon atom by decarboxylation reaction. Now we'll discuss coal-base electrolysis reaction. We have studied this reaction in first PU. When concentrated solution of sodium or potassium salt of fatty acid is electrolyzed, higher alkane is obtained at the anode. We'll discuss the reaction now. Sodium or potassium salt of fatty acid, RCOONA. This is sodium salt of fatty acid. If it is subjected to electrolysis, you are going to get higher alkane plus carbon dioxide plus NaOH plus H2. This is higher alkane. This is sodium salt of fatty acid or sodium salt of carboxylic acid. Carboxylic acid. This reaction is known as coal-base electrolysis reaction. Now we'll discuss one example. When concentrated solution of sodium acetate, that is 2CH3COONA, this is concentrated solution of sodium acetate, is subjected to electrolysis, higher alkane is formed. You are going to get CH3 plus 2CO2 plus 2 NaOH plus H2. This is ethane. This is example for coal-base electrolysis reaction. Now we'll discuss substitution reaction in the hydrocarbon part. It is halogenation. That is HVZ reaction, Hell-Ollard-Zelinsky reaction. Here, aliphatic acids or side chain substituted aromatic acids which contain alpha hydrogen atom, they react with halogen like chlorine or bromine in the presence of red phosphorus, gives alpha halo acids. This reaction known as Hell-Ollard-Zelinsky reaction. Aliphatic acids are side chain substituted aromatic acids containing alpha hydrogen atom. They react with halogen like chlorine or bromine in the presence of red phosphorus, gives alpha halo acids. This reaction known as HVZ reaction. Now let me write the general reaction. This is general reaction for aliphatic acid which contains alpha hydrogen atom. The hydrogen atom which are attached to alpha carbon atom are called as alpha hydrogen atom. Aliphatic acids reacts with chlorine or bromine in the presence of red phosphorus, gives alpha, this is alpha carbon atom, alpha halo acids. This reaction known as HVZ reaction. Now let us discuss the example for Hell-Ollard-Zelinsky reaction, HVZ reaction. When propanoic acid reacts with, propanoic acid is CH3CH2COOH. Propanoic acid reacts with chlorine in the presence of red phosphorus. Chlorine in the presence of red phosphorus. Substitution of alpha hydrogen takes place. This is alpha carbon atom and it contains two hydrogen atoms. These are alpha hydrogen atoms. Substitution, one hydrogen atom is replaced by chlorine atom. Substitution of alpha hydrogen atom takes place, forming 2-chloropropanoic acid. CH3 CHCl COOH, 2-chloropropanoic acid plus HCl, 2-chloropropanoic acid. This is propanoic acid. Propanoic acid. This reaction known as HVZ or Helmholtz-Zielinski reaction. Now we'll discuss electrophilic substitution reactions of carboxylic acid. These aromatic carboxylic acids, they undergo electrophilic substitution reaction. Undergo electrophilic substitution reaction. Next point. Carboxylic acid or carboxyl group acts as deactivating and meta-directing group. Carboxylic acids do not undergo Friedel-Crafts reaction. Do not undergo Friedel-Crafts reaction because carboxyl group is deactivating and the catalyst aluminum chloride anhydrous aluminum chloride gets bonded to the carboxyl group. Okay, they do not undergo Friedel-Crafts reaction because carboxyl group is deactivating and anhydrous aluminum chloride gets bonded to the carboxyl group. That is the reason why carboxylic acid does not undergo Friedel-Crafts reaction. Now we'll discuss nitration of benzoic acid. When benzoic acid reacts with benzoic acid is C6H5 COOH. Benzoic acid reacts with nitrating mixture, that is mixture of concentrated HNO3 and concentrated H2SO4. Gives meta-nitrobenzoic acid. Meta-nitrobenzoic acid. As carboxylic group COH group is deactivating and meta-directing, hence the NO2 plus electrophile attacks the meta position, so we are going to get meta-nitrobenzoic acid. Next reaction is bromination of benzoic acid. Benzoic acid reacts with bromine in the presence of halogen carrier. Benzoic acid reacts with the bromine in the presence of Halogen carrier like ferric bromide FeBr3 gives metabromobenzoic acid. COOH here Br. This is metabromobenzoic acid plus HBr. This is benzoic acid. As we have discussed, COH group is deactivating, but it is meta-directing. Hence, the incoming electrophile in this case Br plus attacks the meta position. So, we are going to get metabromobenzoic acid. This is about electrophilic substitution reactions of carboxylic acid.